Hello students, this is Mr. Ezra. Today we are going to talk about how to solve quadratics by factoring when a is greater than 1. So in the last few videos we've been dealing with situations where a equals 1. Remember in our ax squared plus bx plus c equals 0, we're talking about what's called the leading coefficient. When we say a is greater than 1, we mean the number in front of the x squared part. So let's get started. We're going to do a few examples today, but let's look at the rules first. The standard form of a quadratic equation is ax squared plus bx plus c equals 0. And in order to factor in this with this type of quadratic, we really need things to be in this order for our process to work. Another thing to note is that a should always be positive. So this leading coefficient should be positive for this to work. Remember, you can always add and subtract things across the equal sign to get it into the standard form. But once you get it there, now we can start to factor. So first, put the equation in descending order from highest to lowest power, starting with x squared, then x, then the constant. We're going to see in a second this worked out, listing all the factors of a, then listing all the factors of c. Assume that order matters, and also show the reverse order for each set of factors. And when we have an a of 1, the order isn't as important because the first part is always x times x. But here we're going to have maybe 2x times x or 3x times x or something like that, where the order is going to matter because when you multiply by 3, it's different than multiplying by 1. Fourth step, test different combinations of factors of a and c to find a combination that gives you that middle part, that b part. Step 5, create two binomials with the selected factors of a and the variables as the first term, and then the selected factors of c as the second terms. We're then going to make sure that we got it right by using the distributive property or the FOIL process to test the binomials. And then finally, we'll set the binomials equal to 0 and solve each one for the variable. This is called the zero product property. Sometimes when students see all of these kind of procedures listed out, they get stressed out because it looks like a lot. But when you see as we work through the problems, you can kind of tighten up and it doesn't really take as long as all of this, but this is all of the steps listed out. So let's look at an example that's already worked out. And you'll notice that in this example, step 1, 2, 3, 4, 5, 6, and 7 are all kind of listed out for you so that you can see them. If you have your notes page printed out in front of you, this is already there. If not, you'll have to copy this down, I guess. Just pause the video anytime to do that. So our equation is 5x squared plus 31x plus 6, and our original equation had an equal 0. But for this part, we're only really going to look at, or factoring, the part that is in standard form. Our a comes from the leading coefficient of 5, our b is going to be positive 31, and our c is going to be positive 6. So the step 2 was to find the factors of a. For the factors of a, if it's a prime number, it will just be that number in 1. And you do not have to reverse the order here because we'll handle the reversing of the order on the right side or in the next column for step 3. If this were, let's say, 15 instead of 5, you would have to list out 5 and 1 and check all of these. And if none of them work, then you'd have to do the same thing with 3 and 5, because 3 times 5 is also 15. So it'd be 15 and 1. If this were a 1, it would be 15 and 1. Excuse me, and if none of them worked out, you'd have to try 3 and 5. You have to try all the factors of 15, but 5 is prime, so we're not going to have to worry about all of that. In this problem, we're just going to have 5 and 1. You then go to the last part, which is C, the 6 over here, right? And we'll find the factors of 6. Now, the factors of 6 are 6 times 1. And remember, here we also have to reverse the order and try 1 times 6. 3 times 2 is 6, or 2 times 3. So when the order can be reversed, you want to reverse the order. Another thing I want to mention is here, think about the signs, right? If we are going to be multiplying to get this last term, our signs have to both be positive, or they have to both be negative to multiply to get a positive, to get factors of C. So it's either 6 times 1 or negative 6 times 1, right? Well, since we're adding products together to get this middle term, You'll see that we're going to do that over here. When we add these together, if your goal is to get a positive sum, then both of these need to be positive so that when you multiply positive times positive and positive times positive, everything's positive and it works out. We'll see in later problems that we won't have all positive factors over here. When we test them out, it's really important that you pay attention to the directions here. We're essentially going to kind of foil this. We're going to multiply the outside times the outside and the inside times the inside to check this out. So 5 gets multiplied by 1, and 1 gets multiplied by 6. So 5 times 1 is 5, 1 times 6 is 6, and 5 plus 6 is 11. Now our goal when we're testing to find b is to get this middle term. That is our goal. We didn't get it, all right? So that means that this combination is not going to work. We try the next one. 5 times 6 is 30, plus 1 times 1 is 1. 30 plus 1 is 31. And in fact, 31 is our goal. Once you get what you're looking for, you can stop. You don't have to go any further. There's other possibilities out there, but they're not the ones that are going to work. We found it. This is what we're going to use. So the factors of a go at the beginning of your parentheses, 5 and 1, 5x and 1x, and they get an x on it. So 5x and 1x. And the factors of c that worked in the order that they worked go with the 5 and the 1. So 5x plus 1 and x plus 6. Now you do want to take just a second here and test this out and make sure that you did it right. It's really frustrating to get all the way to the end and get the wrong answer when you could have just checked it to make sure. Okay, so 5x times x is 5x squared, 5x times 6 is 30x, 1 times x is x, 1 times 6 is 6. That's the FOIL process. First, outside, inside, and last that we're doing here. And when we clean up by combining the like terms in the middle of 30x plus 1x to get 31x, we get what we started with, which was 5x squared plus 31x plus 6. It works, so we know that we've got the right factors, and as long as we use the zero product property correctly, which basically just means you set each part equal to 0, 5x plus 1 equals to 0 could work, could make this true, or x plus 6 equals 0 could also make it true. We solve these two-step equations, subtract 1, divide by 5 to get negative 1/5, and subtract 1 to get negative 6. These are the two solutions, negative 1/5 and negative 6. So we got it. Good. For our second example here in your notes, again, anytime you want to, you get to a point where you think I could do this, you want to try it, pause the video, try it, and then let the video catch up and see if you got the same thing. So let's do this one together. I've already listed out the factors of 7. We've got 7 and 1. 7 times 1, 7's prime, so that's the only way that we can get 7 is 7 times 1 or 1 times 7. So the order does not matter for the factors of a. Once you decide on 7 here and 1 here, you can leave it that way, right? But in the factors of c, you do have to check both of the orders. Now think for a second, why did I use negatives here? Well, we're multiplying to get this last term, essentially, right? So it's either positive times positive or negative times negative to get a positive number. But we're adding to get a negative in the middle. And anytime you have that pattern where the negative x and the positive constant is there, both, think of it this way. Here's a little shortcut for you. If there's a positive in the rear, your signs are going to be the same. And you're going to look up here. So this means same because it's positive. You're going to look up here, say they're both negative. We did that in the last question, right? I shouldn't say it, right? Positive here means they're the same. I look up here, they're both positive. So these are both going to be negative. I don't have to try any other combination than negatives. Now, the factors of 35 are negative 1 and negative 35, where I switch the order, or negative 5, negative 7, or I switch the order. I'm going to start testing these out to see what works. Remember, it's outside times outside, so 7 times negative 35 plus inside times inside, 1 times negative 1. We multiply that together and we get, let's see, 7 times negative 35. That is negative 245, I believe, plus negative 1. And you can see pretty quickly that there's no way this is going to work. Definitely not negative 54, so that's a big fat no. We'll move to the second possibility, the second combination. 7 times negative 1. And then 7 times negative 35. And you can see why we have to change the order here, because 7 times negative 35 is very different from 7 times negative 1. Well, we'll test this one out. We get negative 7 plus negative. I made a mistake here. Let's fix that really quickly. Everybody makes a mistake. That should be it was inside times inside, and the inside here is a 1. The inside here is a negative 35, so it should be 1 times negative 35. So 7 times negative 1 is negative 7, and 1 times negative 35 is negative 35. And we put these together, and we get negative 42. And that's a little bit closer to what we're looking for, but it's still a no. Well, we might have to try all these. Let's see. We got 7 times 7 for outside times outside, or 7 times negative 7, plus the inside times inside, which is 1 times negative 5. 7 times negative 7 is negative 49, plus 1 times negative 5. We add those together to get negative 54. We go back and check, did we get what we were looking for? Did we get negative 54? Yes. So that's the one that we're looking for. That's the combination. So remember, when we do this, once we decide, hey, this guy was right, with this guy, this is what works, we can go ahead and put them together. The 7x and the 1x go first. Instead of 1x, I'm just going to write x. And the minus 5 and the negative 7, minus 7, go at the end. They have to go in that order, right? 7x minus 5, x minus 7, so that what we just did works. Now, it's a good idea here to, part of this process is to check this. Did we actually get it right? Well, that's 7x squared, 7x times x. 7x times negative 7 is negative 49, x. Negative 5x for inside times inside. And the last times the last is positive 35. And when we clean that up, we get 7x squared, all right, minus 54, when we add those two inside terms together, 54x plus 35 equals 0. And this is what we started with. So we know that these are the correct factors. It's important that you get this vocabulary down, right? These are called factors right here. We don't want factors here, we want solutions. So the two factors are 7x minus 5 and x minus 7. To find the solution, we take those factors and we use what's called the zero product property. We take the 7x minus 5 and set it equal to 0. And we take the x minus 7 and set it equal to 0. Add 5 to both sides. Divide both sides by 7. 5 over 7 is one of the factors. I'm sorry, one of the solutions, one of the roots, one of the zeros. Those words are used interchangeably. We'll add 7 over here. Another root is 7, so we have two roots. 5 over 7 and 7. You can remember from earlier discussions that there are always going to be two roots for these. There's only one root, it's because there's a double root, which means there really are two roots. We'll talk more about double roots a little bit later. So here are the solutions for this example, 5 over 7 and 7. Before I flip to the next slide, if you have your notes out and you want to pause the video, try it out, and then press play, it would be a good idea to do that. All right, so whether or not you attempted this problem, we're going to go ahead and begin. First out, I'll kind of isolate my equation here, which when I say equation, what I really mean is the standard form of something x squared plus or minus something plus or minus something. Here it's 2x squared minus x minus 6. That's what I need. Again, if there was something on the right side of the equal sign, we'd have to subtract it across so that it is in this form. And once it's in this form, we can quickly identify A, B, and C. Factors of A are going to be simple here. It's 2 times 1. That's the only way to get 2. For the factors of C, let's think about this really quickly. We are multiplying to get this negative 6. When we have this broken out into something, let's say we have x minus 2 times x plus 3, right? When we multiply this out, we're foiling it, and to get the last term, it's last times last. Well, negative 2 times positive 3 is negative 6, but if they were both positive, it wouldn't work. So what that means, the little tip that you can remind yourself, is that if there is a minus at the end, what that means to you as a student is that your signs are going to be different. One sign is going to be positive and one sign is going to be negative. Now, as we work through these problems, we'll find factors of C. Factors of negative 6 are going to be one positive and one negative. So I'll first start with negative 6 and 1. And when I'm testing this out, outside times outside, 2 times 1, plus inside times inside, oops, stray mark there, 1 times negative 6. I think some of you are starting to say, if I were doing this, I wouldn't write all this part out. I would just say 2 times 1 is 2, and 1 times negative 6 is negative 6, and that's okay. You can kind of tighten this up a little bit and speed up, but as a teacher showing you how to do it, making sure I kind of put in every step, I'm going to be pretty thorough. Did I get negative 1, the B that I was looking for? The answer is no. Here I got negative 4. That didn't work. Now, there may be a few students saying, well, Mr. Ezra, what if I put a positive 6 and a negative 1? That would still give me negative 6, and you're right, 100% right. This is another combination. I'm not switching the order, I'm changing the sign. And the only thing that happens when you change the sign is the sign of your resulting sum that you get over here is going to be changed. So instead of negative 4, if you were to multiply this out again, you would get positive 4, which is still a no. So kind of remember that as we move forward, that any of these, when we have different signs, if we get the right number but the wrong sign, it just means that we have to switch the negative to another part. Well, that was a no. It was a double no, actually, wasn't it? So let's look at our next factors of C. Actually, I should have listed these factors of C out. So we remember, once you find negative 6 and 1, you change the order. So we'll do negative 1 and 6. And of course, 3 and 2, so negative 3 times 2. And we switch the order to get negative 2 and 3. All right, so we're going to multiply here, outside times outside, 2 times 6. 1 times negative 1 for the inside times inside. That is 12 plus negative 1, which is 11. 11 is not negative 1. If I switch the sign to negative 11, it would still not be negative 1. So that's another no. Let's try the next one. 2 times 2 for outside times outside, and 1 times negative 3 for inside times inside. This is looking promising. We got 4 plus negative 3, and plus negative is just subtracting, right? So that's 4 minus 3, which is 1. Okay, well, 1 is not what I'm looking for, but it's pretty close, right? I need a negative 1. The signs matter. How could I get a negative 1? Well, instead of the negative on the 3, if I change this and put the negative on the 2, what would happen is this would be a negative 2, and this would be a positive 3, and I would get negative 4 plus positive 3, which would change the sign to be a negative 1. So anytime it doesn't work, originally just change the signs, switch the sign to the other guy, and then you'll get the one that you're looking for, negative 1. I don't have to try this last one because I found my answer. So remember, the beginning of our parentheses, we get 2x and 1x, and you don't have to write a 1 in front of an x. At the end of our parentheses, we get the one that worked, and be careful here because we got so much going on. This is the one that worked right here, 3 and negative 2. It has to be in that order, so it's going to be plus 3 because that's a positive 3, and minus 2. And just to be thorough and check our answer, make sure we got it right, we're going to FOIL this out to get 2x squared minus 4x plus 3x minus 6 down to equal 0. We'll combine those like terms in the middle to get minus x minus 6 equals 0. 2x minus x minus 6 is what I started with. It worked, so I know that my factors are correct. These factors, 2x plus 3 and x minus 2, are correct. I'm going to take those two factors and use the zero product property and set each one of them equal to 0. So subtract 3, divide by 2, add 2. So my two answers, my two solutions, these are called roots and zeros also, are negative 3 over 2 and positive 2. Now, some of you may have noticed at this point that there's a pattern here that you can use instead of solving these out once you get the factors. It's called opposite over coefficient. So the opposite of the constant over the coefficient. Negative 3 over 2. Boom. Positive 2 over 1 is 2. And if you go back and look at the other examples today, you'll see that that works every single time. That the zero product property can be shortened to using the opposite of the constant over the coefficient. Well, we have a few examples, and those few examples took us a while to get through the notes, but as you work through some practice examples, you'll find that these actually can move pretty quickly if you move pretty quickly. Guess that's it for today. I'll see you in class. Have a good one.